All right, let's do an example. Let's say that I have a vector A, and a vector A is 1 meter long and 45 degrees from the x-axis. And vector B is 2 meters long and 60 degrees from the x-axis. So if I were to draw this, it would look like this. My vector A is 45 degrees, and it's 1 meter, and then vector B is twice as long. So something like that, vector A and vector B. And I want to know what is A plus B. I want to know what is this vector, A plus B. My first thing to do is just to find the components. I want to know what is R, and R is equal to A plus B, the sum of A plus B. So first I want to find the components of A and B. All right, so AX is going to be 1 cosine of 45, which is 0.71. Similarly, AY is 1 sine of 45. The sine of 45 equals cosine of 45, so that's 0.71. dx is 2 cosine 60, and 2 sine 60 is dy. A cosine of 60 is equal to a half, so that's just 1.0. And then this is going to be 2 sine of 60, which is 1.7. All right, so now I have the magnitudes for the x and y components of A and B. Then I'm going to add those to find out what is Rx and Ry. And the AX plus BX is going to be 0.71 plus 1.0, 1.7. And then Ry is going to be the sum of AY plus BY. It's going to be 0.71 plus 1.7 is 2.4. Actually, I've kept 3 sig figs, so I'm going to do that here. All right, then the magnitude of R is from the Pythagorean theorem. So now I have Rx and Ry. I have Rx and Ry. And now I want to know what is the magnitude of R. So now I'm forgetting about the vectors A and B, because I've used those vectors to find the x and y components of R. So I can find that R is going to be the square root of Rx squared plus Ry squared, square root of 1.71 squared plus 2.41 squared. And now I'm going to revert back to my proper sig figs, which is 2 sig figs is 3.0. All right, so that gives me the magnitude of the vector R. And now, since I know the x and y components of R, I can find the magnitude of R, I can find the angle. It's the inverse tan of Ry over Rx. That'll be looking for this angle right here. And that angle is inverse tan of 2.41 divided by 1.71, which is equal to 55 degrees. 55 degrees. So my vector R is 3 meters at 55 degrees from the positive x-axis. Let's do another example. I like to do these using tables sometimes. Consider I have these two vectors, A, B, and C, and they're the values given, and I want to know what is the what is R. So R is going to equal A plus B plus C. And I want to know what is the magnitude and what is the direction of R. So my first thing to do is just to find the x and y components. So the x component, for example, of A is 2.236 times the cosine of 63.43 degrees. All right, that'll give me the x component, and that's equal to 1. Similarly, for the y component, I say 2.236 times the sine of 63.43. And that gives me a y component equal to 2. All right, I can do that for vector b using these values. And I find that the x and y components are 3 and -4. Really helps to draw these vectors. So let me draw the vector b. The vector b is 5 meters at this angle below the positive x-axis. So that's my vector b. Notice that my y component here is negative. You'll want to look at the directions very carefully for these vectors and then ensure that your x and y components have the proper sign. That is, what quadrants are you in and what sign does that give you for the x and y components. Doesn't come out in your calculator necessarily. And even if it does work sometimes, it's not going to work all the time. I'll show you some examples later of how that happens. With vector c, notice that it's at 68.2 degrees above the negative x-axis, so vector c is right here. So which component is going to be negative for vector c? Well, the x component is going to be negative. It's -2. That's the cosine of 68.2 times 5.39. Gives me -2. And then the y component of that vector is 5, +5. So I want to know what is r a plus b plus c. Then I can find the x component of rx. It's just going to be ax plus bx plus cx. The y component is ay plus by plus cy. I can find those values. I'll go back up to my table. Adding up these values will give me r. The x component is 4 minus 2, that's 2. What's that? 7 minus 4 is 3. So my x and y components of r are 2 and 3, respectively. This is 2, and this is 3. And if I want to find the magnitude of r, I say 2 squared plus 3 squared. That is the root of 4 plus 9, which is 13, which is 3.6. And then if I want to find the angle, I do the inverse tan of the y component over the x component. And I find that it's 56 degrees. Now let's say, for example, I wanted to find a minus b minus c. Then that means for my x and y components, whereas, for example, before, for the vector b, I had x and y components of 3 and -4. Now my x and y components are going to be -3 and +4. So I'll just negate both of those components. So before the vector, so I'll just negate both of the components. So then my Rx will look like this. I'll have 1 minus the x component of b, which is 3, minus the x component of c, which is -2. So you see, this is where I negated that x component of b. And so let's see, that's 0. And then Ry is 2 minus a -4. That's the y component of b, minus 5. And that's equal to 1. So now to find the magnitude, I say 0 squared plus 1 squared is equal to 1. And then my angle should be Ry over Rx. That's, of course, going to equal 90 degrees. Those are good examples. Very much see a vector addition or subtraction problem on the next.